Hi guys, Shouvik here. Welcome back to YouTube channel. So today we'll solve another question from Leetcode itself. So let's get started. Yes. So today we have this count complete subarray in an array. Yeah. First we will understand the problem statement. Then we will build our intuitions, and post that we will jump on the code iterations. And after that, time and space complexity analysis that we generally do, that we definitely do. So yes. So on that question, they have given an array nums consisting of positive integers. And we call a subarray of an array complete if the following conditions is satisfied. We call a subarray of an array complete if the following conditions is satisfied. What conditions we have to satisfy? The number of distinct elements in the subarray is equals to the number of distinct elements in the whole array. Right? The number of distinct elements in the subarray is equal to the number of distinct element in the whole array, and return the number of complete subarray. A subarray is a contiguous non-empty part of an array. That we all know. So I think the problem statement is very crisp and clear on the first go. You guys can read it out and understand it. So in the array we have to find all the subarray which actually holds on that particular subarray. If you query with how many distinct elements on that particular subarray, it should have the same count as of the whole array. So on this example, how many distinct elements we have it on the entire array? So it is 3, right? 1, 2 and 3. 1, 2 and 3. So on every subarray, the expectation is it should also have three distinct elements, right? So here you can see, right? One is like 1 3 1 2. Another one is like on this how many distinct elements? 3. Here also 3. Here also 3. Here also 3. So there are 4 complete subarrays of this nums array we can form. Very straightforward. For this you can do your own, but there you can get 10 complete subarray of it. 10 complete subarray of it. And on the constraint you can see it's on the range of 1000. So if you can write something like big of n squared kind of things, you can generate all the subarray, and when generating the subarray you can basically check how many distinct characters from L to R it have as. So like this way you can submit a brute force with big of n square. That is also going to be accepted. But yeah, we will not going to discuss the brute. We will directly discuss the optimal solutions on this particular video. So let's focus on the optimal solutions. Yes. So on the intuitions, on intuitions perspective, if I just touch on the brute a little bit, otherwise you will not going to get the optimal solutions feel of that optimal solutions, how we can derive the optimal solution, how we can reach till the optimal solution. So on brute, what you will do? On brute, what you will do? So on brute, you will run a for loop for L in range from 0 to n, and for R in range L plus 1 to n, right? L plus 1 to n, and you inside this you are considering the portion of the array. You have to choose how many distinct count this particular subset has, this particular subarray has, which is of nums of L to R. How many distinct elements we have it. You can take a dictionary and to basically track when you are moving your R pointer. You can also increase the counter of them. We can also increase the counter of them. So like this way you can do it. But the gist which I am trying to build the intuitions on your brain, we have 2 pointers. One is at L, another one is R. So you are considering a window of size L to R, right? How we can reach to the intuitions, that is actually the tricks on every interviews you are going to appear. So what actually you have to look for? So you have a L and you have R. So you are basically trying to find how many distinct elements inside that LR subarray we have it. Inside that LR subarray we have it. Very straightforward. And when we have a window, how we can land on the intuitions of window? Because we have 2 pointers L and R. We have 2 pointers L and R, and we are considering a subarray of L to R. So that means we have a window. We have a window, and it is nothing but a sliding window. So on that sliding window, what actually making your complexity as high? So we are pretty sure that we are definitely moving our right pointer till end. We are definitely moving our right pointer till end. But for this R, how many else we can build? How many else we can build? Which is basically from that L to R, from that L to R, from that L to R, from that L to R. It holds all the distinct elements which actually held by my that subarray. What the subarray? My original array, right? Like this way, we have to find all the else. We have to find all the else. So I think if you guys are following our sliding window playlist, we have, if you guys mostly already have been solved by on your own this problem, because we have solved more tougher problems of sliding window, and this particular question, I think just the last sliding window questions we have solved, it is just a like same code. Like I have to say it is a easier versions of that for sure. So if you are at R, so you are basically looking for what actually the else you have to find what actually the least else. So if that is the least else, what it is of least else. So we are trying to move our L pointer to extreme right. After that, so that is the point of validation. So till this it is valid. But if you are moving your L pointer to just after this, then you are mostly violating what you are violating. The window you are considering currently, L to R, is having all the distinct elements. So but just before that it is valid. So can I say, if till this L it is valid, so all the left are going to be valid. Yes, very intuitive. So from this L to R, if you are able to get all your distinct elements which actually held by your original array, then from this R to more left, you are definitely able to, that subarray are bound to like follow the principles, bound to be good subarrays, bound to hold all the distinct subarrays actually the original array hold, because this subarray is actually hold all the subarrays. So this actually definitely bound to hold, this definitely bound to, because on left we are basically consuming more elements. So by consuming more elements, it is bound to lie our entire subarray distinct, actual original subarray distinct elements. It is bound because that is the smallest subarray from R to the left. Currently left is standing, it is the smallest left. So all the lefts are definitely valid. So that's actually the intuitions we have to be follow. So now I am just writing the pseudocode. Just follow me, guys. If you are not able to understand, I will definitely suggest, please go to these particular explanations once more time and you will definitely get the gist. But after the pseudocode iterations, this particular intuitions, if you are not able to feel, so you will definitely able to feel so how actually it is work. So we are definitely running a for loop for our right pointer. We are moving from 0 to n. We are definitely moving. So n means n minus 1. And for every right consumptions, I will carry a default dict. I will just increase the counter of it to plus equals to 1. And previously I know, let's suppose I have a distinct count in the entire array, in the given array. It is nothing but what it is, set of len of, sorry, I wrote it reverse. It is nothing but len of, you can pass your given nums to a set, then it is generated distinct and you can take it length. So that many distinct elements our original array have it. So we can just compute it that on. And now we can start with a count variable with 0, because we have to be very sure when it is hitting the count to be our distinct count, then on that means we already have a window, and now we have to reach a point of invalidations by moving our left pointer. We have to reach a point of invalidations by moving our left pointer. That is very standard things we are doing from last 3, 4, 5 videos of the sliding window. So if you are not following, I am highly requesting, please guys, please follow the sliding window playlist. After that you will try to solve this question on your own. I am 100% sure that you will definitely able to solve it. But please watch the first 1 to 2 videos of sliding windows, or the very last video that we have uploaded. That is just like easier versions, I have to say, of that particular function. So on right pointer we are increasing the particular elements count, and we are moving further. And before that just incorporate a check here. If my dd of nums of R before increasing. If it was 0, then that means you are altogether encountering a new elements. You are altogether encountering a new elements. Then you can increase your local count also. You can increase your local count also to plus equals to 1. Definitely we will do. And now the point is how we can increase our left pointer. So what is the first points you should have to think to increase your left pointer? What is the first point you have to think of to increase your left pointer? It is nothing but when your count is altogether hit your distinct count. So that means currently you have a valid window. You have a valid window of L to R, which is holding all the elements count is your distinct count. That is your original array. Original array have already hold the how many distinct elements. So it is already holding this. It is already holding this. So that means now it is a point to move your left pointer to a point of invalidations. To a point of invalidations, because from its left, because now we have to move our left pointer to a points of invalidations, and just off the left of the point of invalidations of the left pointer, all the left are valid. All the left are valid, right? All the left are valid. So now see me. Just follow me, guys. How I am writing the inner things. Just do copy paste of the entire things. So that is the standard templates I am following, and I'm definitely sure if you are able to write your right pointer logic, just do the reverse of the left pointer movement. So what we are doing initially, we are increasing our right pointer. So right here, if we are moving our left pointer, dd of nums of L is going to be minus equals to 1, right? And if at any particular point dd of nums of L is going to be 0, so that means you are altogether losing this element. So that means your distinct count of the current window should be decreased. So you can do your count minus equals to 1. Very simple. I am just doing the reverse things. And here we are basically, here maybe like after this maybe we have some r plus equals to 1 we don't have to do, because we are running a for loop which is doing that thing. So but here we are running while loop, so we have to do a L plus equals to 1. As simple as that, guys. I just write the reverse of it. Just write the reverse of the right pointer movement, and I am able to set my left pointer to a point. So when I am at this point, so my left basically point to first point of invalidations. First point of invalidation. So all of its left are valid. So what I can add to my answer then, as it is a zero based. So my left is point to the first point of invalidations, so I can directly add a L pointer. So if you are not able to understand, just take an example. 0, 1, 2, 3, 4. Yes, this should be fine, right? 5. Let's suppose your R is here and your L is pointing to here. Which is the first point of invalidation. So that is the first point of invalidation. So I know this should be in my range 1, 2, 3. How many I got? So for this I should have a valid L to be 3. So that means where my L is actually pointing, I know all of its left are valid. So L is pointing to a invalid index. So its left should have that many elements, because it is of zero based. Very intuitive. So I am just increasing my answer to plus equals to L. Yes, guys, and finally you can return your answer. Yes, the problem is as simple as that. The optimal versions is as simple as that. We didn't do actually anything. So we are just writing our standard sliding window template, which we are already explained from last 1 to 2 videos. We have just given high level overview of that, and we are able to solve this particular problem. And I'm repeatedly requesting you guys, please go to the sliding window playlist and please watch video at least 3 to 4 videos, because there I have basically tell you how to actually sliding window base is built. Because if your base is strong enough for sliding window, this type of questions is altogether a kind of cakewalk. So please watch those videos. I'm repeatedly requesting to you guys. Now here you can see I have written the exact same code. I have taken a distinct count, that is len of set of nums, dd default dictum in count answer n. I have just initialized all the variables set, and I am moving my right pointer. When we are moving, before I am checking if that elements is altogether new elements, its count is 0, then we are considering, okay, we have encountered a new elements of count, and we have also consume it. And when my count is altogether hit distinct count, move your left pointer. How you are moving? Decreasing from your frequency map of its count. And if its count to be 0, so that means that particular elements you are altogether lose. So you have decreased your counter. You have decreased your current L2R distinct elements count, and like this way, and also you are moving your left pointer. And finally, after this while loop executions, you have your L pointer standing at a particular point where it is pointing to a first point of invalidations from L to R. So you can just add to answer plus equals to L as index at 0 based. So just adding to that particular value, your answer is going to be updated. Just that we just saw by one note array creations. Finally, we are returning our answer. So yes, guys, this problem is as simple as that. And if we can quickly discuss the time complexity of this particular problem, so it is nothing but standard 2 pointers or sliding window we are doing, and we definitely know the complexity of sliding window. It is big of 2n because right pointers can visit all the elements at max 1 times, left pointer can visit all the elements at max 1 times, so all the elements of this array can be visited 2 times, so that means 2n. Very simple. And here you can see like we are converting to a set of nums, so this conversions is also going to be a take of big of n for sure. So please take a note of this, like this small things, guys. Actually, if you are explicitly tell on the interviews, that actually make yourself like very different from the other candidates. They mostly like 30 to 40% candidates maybe are able to write the entire sliding window code on the interview, but they are on like time complexity analysis, they write something like big of it because we are using sliding. But no, guys, like please like explain your every line's time complexity on the granular basis. If you have that understanding, that is actually make yourself obviously different from the other candidates. So sliding window big of 2n, and this conversions is making a big of n, so the actual time complexity of this particular submissions is big of 3n. In big O terms, it can be big of n, but actually it is big of 3n. And on space perspective, we are using a default tick, which is going to be a tick of what? Big of n. So yes, on space perspective, we are consuming a big of n space. So that is the most optimal solution time and space complexity that I am able to figure it out, and I'm pretty sure that my solutions is almost like 95% faster than all the submission, and it is the most optimal solutions. But yeah, for this particular solution, they are accepting big of n squared also. You can do and get an AC, but I will definitely suggest please do with the most optimal solutions, because on interview they are mostly going to be looking for this kind of solutions. Yeah, so that's it, guys. That's it for this particular video, and if you are able to understand till this point, so I think you guys are already doing. Please do subscribe to our channel, and please share the videos to your friend circle who are also preparing for top product based company and brushing up their PSS skills, and please turn on the notification so that when we are going to be live to our next video, you will get the notification as soon as possible. Yeah, yes, guys. So that's it for today. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.